So, myself Shahin Ramkrishna. I'm with 21 CS. I'm a software engineer. I've been working on VSEn since past 3.5 years. Okay, so today I'm just going to give you how to set up openSSL on VSEn, how to use it. I won't be getting into what is an SSL or how the communication happens in details. It is just an overview to how to quickly set up your applications like FTP or Telnet or anything else to use openSSL. So why openSSL? It's a security concern actually. When you have an open port or open communication to an external machine, so you have to ensure that the communication between these two entities is secure. So one way of ensuring that security is to encrypt the message. Actually, you're giving a login password or anything just ensures that an authenticated person is accessing the machine, but still somebody can still listen to that information that's been transmitted and they can intercept it and get the data out of it. So in order to prevent that one, you can encrypt it. So for that one, the protocol introduces SSL, now so-called it's TLS. So VSEn comes with an open SSL, that is an open source collaboration of open source teams collaboration for SSL protocol implementation. Okay, so openSSL 1.1.t is the version right now is with the VSEn. So openSSL provides a lot of features actually, but from the VSEn when you access, not all features may not be accessible to you, but it will provide you all the necessary features to establish a secure communication between two machines. Okay, so that in order to establish a secure communication, you need to follow certain or create some what we call artifacts. It's also called certificates. Okay, and these certificates establish a secure means to communicate within an external machine. So these certificates can be generated internally, or you can depend on an authorized or a well-known entity to provide, third-party entity to provide these certificates for you. Okay, so they will ensure the security of these certificates or the algorithms that is being used to generate it.
Why would you go that way?
I'm sorry?
You created it yourself, right? Is it more secure to go outside?
Yeah, if you are, sorry, if you are your intended use is to within the network, okay, your internal organization network, you can always send. But if you are trying to let a third party or your own customer to access it, okay, then how to ensure that? And for example, when you are accessing a website, you might always see that HTTPS. Okay, so okay, it has a certificate, that's a secure one, but how do you know that that certificate is original? So that's where a third-party entity, I can't remember, but I can show you later on. Okay, there are so many third-party entities, they generate the certificates for you and they provide the intermediate certificate that you use to sign these certificates to your Windows or Mac or anything. So that when you open these browsers, it will check to the certificate repository that's already available in your system that is provided by these third-party entities. Okay, then it will validate, oh yes, it is available. Okay, this is a genuine one. That's how it validates. That's where the third party comes in. If it is just for within a network that's already known to you, it's not from an external party you accessing it, then you don't need it.
And I understand what you're saying, and within my network, it's inside my company, but most of my programmers work remotely nowadays, right?
But we VPN to our network.
Yeah, exactly.
Yeah, there are different aspects to the security actually. VPN is one of those actually. Yes, because VPN is already ensuring as network security. Okay, on top of that, when we are ensuring that the applications that is used through the network itself is secure. Yeah.
So is it an acceptable alternative or reduce the requirement for having a VPN? So if I encrypt my telnet cell.
Good question. It's a good handle when the VPN is not available for that purpose, because the customer or whoever's coming in can't be given a VPN.
Right.
So
But I wanted to kind of expand on what was being asked.
Yes, so
Is there a reason why we shouldn't consider that?
so the thing is, the security has different aspects to it. Okay, one, if you want to access a remote computer, first of all, you need to have access to that remote network itself. Okay, if the network identifies you as this IP address, I don't know this IP address, I'm gonna block it, because most of the people who are using a home internet does not have a static IP address, so you cannot register a static IP address. So every time you connect to internet, you are getting a dynamic IP address, and the firewall, okay, at the remote end does not recognize you. Okay, so that is only one security. So VPN bypasses that one, actually not bypass, actually VPN ensures that the one who communicating with it is already a known entity. But within the network itself, there will be different systems. Okay, maybe some system that you are not allowed to access, but someone else from your company is able to access, actually. So in order to access that one, you should have another layer of security. Okay, which ID, who access to these IDs can only access this certain IP address. So that is a different level of security. And within that individual system, a port you are accessing it, then now within the network, it's not encrypted. Okay, because it's not SSL or anything like that. That is still open within network. Anybody who access to the VPN still just listen to it. They can listen to the packet, maybe they can decode it. So that transmission, that encryption, that is what TLS bringing in. Okay, in other words, it is not protecting your network. It is just making sure that even there is a leak, the data is not exposed. That's what it's doing. So in order to create a network SSL connection, you need to create some certificates, and it will provide, the certificate is nothing but a configuration, say you can call it. It provides you a certain means of what algorithm to be selected, okay, what kind of key length to be chosen, and which level of SSL can be used. That also can be controlled by the certificate. And the certificate has different uses, actually, depending on how you are using. It's just for authentication, okay, just for the signing purposes, just for the encryption, or you can use it all for all of these features. I will show you that later. So this is just a quick overview of how an SSL communication happens, actually. So a client triggers an hello, okay, then the server responds to an hello, okay, if it is known to each other already, it communicates. Then server sends a certificate, okay, then server key exchange happens, then server hello done. The key, before the key exchange within the server, there is a key cipher spec specification happen that identifies which key to be used, okay, followed by then key exchange from the client, then client change cipher spec, then client handshake is finished, then the server select the cipher spec, then server handshake is finished, then the transfer happens, then the close notify. So this is a simplest one. This is TLS 1.2 type transmission. In TLS 1.3, there may be extra steps, actually. So each protocol, when the version changes, they may introduce a certain extra feature, and some of the steps could be skipped also. So in order to use openSSL in VSEn, you might need, first of all, VSEn, the minimum version is 6.3, that is what the required. Okay, and you can use the TCP IP from CSI or BSI's TCP IP, IPv4, so IPv6, and you can use LFP in VSEn. Okay, so both of these TCP IP providers provide FTP capability and the telnet. For the LFP, we provide a virtual FTP server. Okay, so you can use the virtual FTP. There is no telnet. So in order to generate the certificates and all, we also provide a connector-based application. It's a keyman, okay, that allows you to create certificate that is compatible with CSI's SSL engine called CSI NTSSL. Or you can use if you choose to use openSSL, then it can create the PEM format files. So because openSSL supports only PEM format files. So it's just a demo. So once you install the keyman, okay, you can start the keyman, then you will see Like, let me make it bigger. It's better now? Okay, but still you can't read it, but still I say, okay. So you can use Keyman to generate the certificate, okay. So you have option to create each component of a certificate individually. It's this one is to generate RSA key pair, then is to DH palms, or if you intend to use ECDHE certificate ciphers, then you need an EC key. Okay, then you can generate an EC key using this feature, or you can use a single click wizard. So that's which I'm going to show you. It needs a active connection to VCS. Okay, so that's my configuration over there. Okay, so that's my IP address and my VCS port and my user ID I'm going to log in, and VSEn job class, my password, and the crypto.keyring. So in VSEn crypto.keyring is where all the certificate intend to store by default, but you can change it. But there may be some application that is looking into crypto.keyring. Okay, then the certificate member is demo01. You can see that PRVK cert and root, these are the three types of files that is CSI uses for their CSI NTSSL engine. Okay, but for the openSSL, there will be a single file with the same name and with a .pem extension. And that is for the cert mapping member is just a user ID mapping member that is not used right now. Okay, rest of the information is just for the how to connect to TCP/IP. So it requests for you to save a member locally, and it asks for a password. The next is to create a keys. So length of the key you have to select wisely, because anything that is more than 1024 might need little extra processing in the system. Okay, system level. So right now the keys is generated locally, not a problem, but still when the server and the client communication happens, they will have to generate another parameter key for the encryption that also will be of the same length. So careful of that one. So if you need a cryptographic accelerator or cryptographic card in your system to make it performance optimized. So this is the DH key length. Okay, there is an error. Make sure that you don't get this error. Go back. Yep. Okay, so now that is a valid key. Next to the EC key generation. So the first one is what you are creating is a CA root, is a certificate authority root certificate. Okay, this is used to sign. You can use this certificate to sign any other certificate directly. And if you have this in your certificate repository, then any servers that is sending certificates signed by that can be verified using this certificate. Usually we keep like a chain of certificate, like a root certificate is there, then an intermediate certificate authority. Okay, and this intermediate certificate authority is the one that is used to sign the rest of the certificates. So this is the server certificate. Next is the client certificate. Just name it as a client for now. So if I click a finish, it will automatically cataloged into a librarian. Okay, in the library crypto.keyring, but this is for the CSI only, so I won't be doing it. Okay, instead I will close it, so I can see all the files or certificate I have generated already here. All you can do is go to the file and save SPM on VSEn. So that's my VSEn machine. So creating, I already have a demo one. Gonna delete it. Okay, disconnected. Okay. Yeah, so I already have one demo.pm, so I'm going to delete that one. Okay. Yeah, so now I'm going to upload this as a PM. So you can select save as PM on VSEn. So it's already connected. So the PM is successfully created in the crypto.keyring. Just do a refresh. So I can see a crypto.demo.pm here. So if I open it, I can see all the three certificates I created, and the private key belongs to it, along with a DH parameter at the bottom. Okay, so the EC key that you generated will not be part of it because it also has a tag private key, which is actually not a private key. So it needs to be uploaded as a ECKey.pom. So ECDH key. So that will be uploaded ECDHkey.pom. So I'm not connected, it's disconnected at the bottom, so connect it. Oh, it's already existing. Let me delete the old one. So that one is uploaded. So there is the ECDH key. So your certificate and the ECDH key both are ready. So that's how you use a keyman to generate the certificates and all. Okay, now back to the presentation. Okay, so now you have certificates already. Now how to configure your application to use these certificates. So before that, VSE provides something called a multiplexer. Okay, that's a very useful one. So what multiplexer does is, if you have multiple TCP/IP stacks, it lets you have a flexibility to configure the way you want. For example, if you want the first TCP/IP stack to use CSI SSL, you can configure that one to use, and second one to use openSSL, you can configure that one, and depending on your application, you just have to specify the system parameter 00 or 01 or whatever the socket that you provided, so it will pick that one.
Full screen?
Oh, sorry.
Now, we do not, BSI does not recommend using IJB SSL LE as the SSL phase for our product. But IBM, but 21st Century wants you to.
So, yeah. So,
Regarding that topic, but then again, it's the question, would you get the support if there are issues? Because if you want us to help us, then we need to go with what we recommend you. If we're going to get all the support from BSI for that, then feel free to whatever BSI tells us. Give us a try with BSI.
okay, let me continue. Okay, so this is a EDC-TCP/ME as a macro. Okay, that's been having the parameter sysids. Okay, so you can specify up to 99. Okay, and there is a 4 variables, additional variables. One is phase, SSL phase, ESA phase, and ESA SSL phase, which are not shown here actually. Okay, so the default values are EDC-TCP/V. Okay, and if you didn't specify SSL phase, the same value that is specified for the phase will be taken for the SSL phase as well. And for the ESA also is the same case. It's not here. I will show you that one later then. Okay, so here if you look at this one, this is for the CSI. By default it's a TCP/V, and this is for the BSI. Okay, so in this configuration, if you are using SSL phase, then it will be same as BSD-TCP/6. Okay. This view is just for the show. This is not an actual definition. This is a wrong definition. Okay. If you cannot have both on 0101 unless you comment out 1. Okay. Yeah, this is commented out. Yeah. So if you intend to use openSSL, our recommendation is to use SSL phase as IJB SSL LE, because that does the initialization of metal C environment that is required for the openSSL IJB SSL module to use. So the IJB SSL M is the openSSL phase, which is built using the metal C. For that reason, it need to, before you invoke the function calls and all, a metal C environment to be initialized. Okay, so if you are bypassing the IJB SSL LE and invoking through your own application, then it's your responsibility to initialize the metal C environment prior to the function calls. So BSC does that.
We do that.
Yes.
We do that.
Oh, added to that, this skeleton is available in the ICCF 62 library. You are allowed to customize it. You can customize as you want. So 21CS TCP/IP for VSEn or CSI TCP/IP. Okay, this is just general information how to use it. So with the CSI TCP/IP, you can enable using openSSL at any time using a TCP/IP command, AR command, or you can use it into IP init. Okay, openSSL on. Or you can use a JCL setbomb tri-cervical to openSSL. If you want to switch between openSSL and CSI NT-SSL, you can use the same parameter to being set to CSI NT-SSL. So this is a sample of how a CSI FTP SSL versus a non-FTP. So that's above is the non-SSL FTP daemon definition that is included in the IP init of a TCP/IP. Okay, and the bottom one is the SSL enabled FTP daemon. Okay, so these are the minimum parameters that you require: SSL to be set to yes, SSL key to set to the member without the extension, and the SSL version that you intend to use. Similarly for the telnet. So I have seen that sometimes those who configure for the telnet use the same parameter for the FTP. Okay, so here SSL library is crypto, separate SSL sublibrary is keyring, and this member is VSE50. In the FTP, it was a single one. So the same way, try to configure it, and it did not work. Come work. So here the SSL version you can use is TLS 1.3. Now the BSI TCP/IP or IPv6 for VSEn. So IPv6 for VSEn provides both IPv4 and v6 support, and it's from the Bernard software. And the BSI does not have their own SSL engine, so it is directly invoking the openSSL. Okay, so the only SSL supported is openSSL. There is no switching between another SSL engine. So this is the FTP, not FTP server and the FTPS server difference, how they configure it. Okay, you can see that. Okay. Here is just open where which one port is being opened, but their XTLS with the library name, member name, and the version to be specified, followed by the OTLS command. Similarly for the telnet, the similar command that is used for the FTP to be used in here. So this is how you enable a normal telnet to use SSL or normal FTP to use SSL. All right, so these are some JCL set forms available for openSSL to control its behavior or to use some extra debugging. Okay, the first one let you help choose the minimum SSL version, and the second one help you choose the maximum SSL version. Because by default a communication is initialized, the server and client will come into an agreement that whichever is supported by the common maximum, it's been selected. And SSL CPH, $CPH let you select the cipher suites to be used for that kind of connection. So anything other than mentioned here will not be used. And SSL debug enables a debugging mode. And BPX GSK specifically for the OLTP. Okay, in order to use OLTP to use openSSL, IGB GSK OS to be set, and the encryption to be strong, set in the DFH SIT. This is just an option to divert the trace to a member name, but not advised, because this is going to be very IO intensive. So you will see responses very slow. You might get disconnections and all. Okay, yeah. And this one is crypto accelerator, use of cryptographic accelerator, yes or no. And this is from the CSI. Earlier it was CSI's APIs used, so whether to use the CSI security APIs to be invoked or not.
Yes. The default is yes.
Yes. The last one is a new one. Okay, so this is because not all SSL applications are developed as per the standard. Some just disconnects it, just go away without even telling the server, okay, I disconnected, or the server simply disconnecting without sending away notification to it. Okay, so a normal SSL disconnection should be one initiates it, sending out the close notification, and other one acknowledges it. So this one introduced recently as per requested by Jeff Bernard. Okay, so the full is default, so that will always try to send out a notification and wait for an acknowledgement and see second notification. So if you use quiet, it will set a parameter. I forgot the parameter name. SSL quiet shutdown, SSL underscore quiet underscore shutdown. It will set it so there won't be a waiting for the acknowledgement. It will just send out a SSL shutdown notification. Similarly, the partial is also like sending out SSL shutdown notification, then the socket just goes down, but there is no parameter set to the SSL quiet shutdown parameter set to 1. So that's a new one. You need to install the latest PTF for that one. I don't know the PTF. So I will show a little demo of that one too. Okay, good. So it's the same configuration that I shown you earlier. Actually, I'm just it's nothing different actually. You see. Okay. Yeah, so I'm gonna submit this one. Okay, the rest of the steps is just to delete my previous configuration for the CSI TCP IP and just to include this one. This is cataloged as an IPFTP.L member, so that will start.
Rex equals yes parameter to port.
Which one?
Rex.
Middle of the page.
Middle of the page.
Yeah. Thanks.
Second line on the screen.
I understand.
Oh, yeah, that's also up there. Yeah.
That is CSI some parameter, FTP parameter. I think Rex executable, something like that. I don't know. You can invoke or something. I don't remember what it is. Yeah.
Yes.
Yeah. You just have to focus on this one. Come here. These three. That was the primary objective. Okay, so let's submit this job. Okay. Okay, so that one is loaded. You can see that FTP SSL is now listening at the port 2121. So I usually do a quick check using some utilities, openSSL utilities available actually, to make sure that SSL is enabled properly. Sometimes it just comes up and says that FTP SSL is enabled on the port and all, but it may not be actually SSL because there is no certificate sent. So openSSL provides certain utility as a, again, that is too small. Yeah. So it's an S-client utility that can use to test that SSL and enabled on a port or not. So here is the same machine. I'm trying to connect to the 2121 port, and the objective is to try to establish a 1.2 based connection.
In your example, that's 1.3, wasn't it? That same version number?
Yeah, 1.2 and 3, yes. So there's the information. Okay, this is all from the certificate. That means that FTP server sends a certificate, and the openSSL was able to parse it, okay, certificate, and extract the information. That's what you see in the screen. So here is a certificate chain, okay, signer intermediate certificate, and here is the server certificate, yeah, the protocol information that you have provided, the session keys. Cool. So here you can see the SSL is enabled on that FTP port.
At the beginning, you showed us the typical transaction for TCP/IP. You said, hello, hello.
Oh yes, yes. Okay, exactly. Yeah, so it's all done already. Okay, that's very fast. It's all done actually, but all the information that happened in that one, so here it is showing. So I do not store the certificate I used to sign this one in my repository. So that's why very first time it gives you this kind of message, whether to accept the certificate authority or not. You might have seen such messages when you are accessing the browser. It may say that we cannot recognize this service provider, certificate provider, so you have to accept it at your own expense. Yes? Yep. So the connection is established. So you can see on the console as well is using the data SSL. So these are the ways you can configure the SSL and make sure that, okay, SSL is actually enabled and the communication is using it. So that's all. Any questions? Oh, sorry. Yeah.
Is there another tool besides Keyman that we can use for this?
Oh, yes, yes, yes. Even this, okay.
It comes with, download it.
Yeah.
It's free.
Yeah, given is free. So openSSL utility can be used to create the SSL. Right now I showed you how to connect to SSL client and check it. So openSSL, this one allows you to create it. I have some script to create it. I can show you that one. I can't read this one. Can you? So, yes.
Actually,
Hey.
I've done over some with the CSI, TCP/IP stuff. It's important that Keyman is acting as a certificate authority. You say that's true because it is pretty self-signed. And what I'm saying to these customers is you shouldn't really use that type of certificate. You should generate a certificate request.
Yes.
To who's the big guy?
Yeah, no, you can do that in the Keyman as well.
Which means that we trust you will have that.
So, yeah. So you can import the items. Yeah, I do not have one to show it actually, but it's possible. I'm just showing that import item from file. If somebody gave you a intermediate certificate, you can just export it, and you can generate the request certificate sign request from here. Actually, there are options for it.
The idea of this is a test play around.
Yeah,
So,
that's right.
thank you.
This is
Free. Yeah, you're pay for a real certificate.
yes. So the paid certificate is again required if you have like a vendor or somebody who's accessing your machine from external source, and to make sure, tell them that okay, this is the original server you are accessing. So for that purpose you can use a third party, so that you don't have to send a certificate. Even when you send the certificate itself, that can be corrupted. So a third party will manage that one. I would like to show that part as well. As I said.
There's an O'Reilly book on openSSL where you create your own certificate authority, and you can do the same things here, basically.
Yeah, that's what here is actually. Yeah, so this is actually what is showing. This is another script that is not related to Keyman. I'm just using the openSSL utility. So I have like a root certificates I'm creating. I'm just setting up the initial parameters on here. Yeah, so this is a standard of like a different size of key I'm created, and the actual function openSSL calls are here.
So openSSL has functions built into it that can also trigger RIT.
Yeah, some utilities are there. Yes. So it's a utility for the openSSL from the community. You can download it actually. So you can see here actually, there is the CA configuration certificate is being generated here, and validation, all these openSSL commands actually. So you can do the same thing. Even when you run the Keyman, actually Keyman, some of the screens, Keyman shows it. What command can be used to generate the same? It shows it actually. Yeah, so if at any point, if you already have a CA or intermediate certificate provided by a third party, you can replace that one with the provider one, and you can use that one to sign rest of it. So the sign, verify. Let's verify. Let me see.
Just want to understand you a little bit. If you this be for development and initialization, openSSL, and then if you were to work with a vendor who did require a site, you would then purchase that certificate from somebody who provides certificates. How's that work?
So you're setting up a server, and you're gonna get a certificate. But if you're a client, you have to shop there.
Okay, so you get my key.
Yeah.
Well, if it's signed by a well-known certificate authority, that would imply trust, so you don't have to go. You don't have to go check it out publicly. Well, because it's signed. So I mean, even if it were not signed by a publicly, if it were not signed by a well-known certificate authority, the alternative is you can call them up and I guess, or somehow communicate the public key to them so they can trust it.
In general rule, how often should you be changing the certificate, or just one and done?
Google thinks every 3 months now.
Every 3 months?
Yeah.
I think that's like a new rule that's like effective like next year. It's going to drive people crazy who have to maintain these certificates. Because right now it's 20 years.
So it's like that usually, as I said, there's a chain of certificates. There is a root certificate actually, which probably have a longest lifetime. Then there is an intermediate certificate that probably have a little bit less of that. But anything that is signed with this intermediate certificate, it better not give too much time, like maybe maximum 1 year or less than that actually. Then every time, thing is, you can always sign a new certificate with the same thing. And as long as this is out there, it still be valid. That certificate, any certificate signed by this one at any point of time still can be validated by the same intermediate certificate. So this is Microsoft's certificate repository. Okay, you can access that one, because if your VSE is a server, actually, you got a message saying that, okay, I don't know this certificate. That's because it looked into a certificate store of Microsoft and it is not there. So you can always bring the certificate and add into a trusted root certificate authorities. Here, oh, yeah, I was trying to remember the name, DigiCert. These are the some certificate authorities that you see here. Yeah, so.
I'm hard of hearing, by the way, so I
Oh, I'm sorry.
barely heard you.
Sorry, I'm talking over my shoulder a little bit too.
Anyway, I was gonna say, I think what's going on is just going through these steps isn't that bad. We have customers always trying to bypass it, and literally in our manual, we have printed a certificate, a private key, and a root. And so you could just copy and paste it into a Microsoft shop and be done with it. Well, what's wrong with that? Your key is in public domain, there's no security to it all, so we removed that. Yeah, but yeah, we could provide them to you directly, but then you don't have any security. It's the whole point of the thing. And these steps are, I like the cert one. I don't know if I know if the cert generated anymore, but they're more and more getting rejected due to strong requirements, right? Unless they more than 6 years, perhaps does.
Yeah, because if a third party provides a certificate, you can always request the certificate in the PM format and put it in the crypto.keyring, upload it there, because we have customers who already done that actually. The third party certificates they are putting in there. Yes, so that's enough. That will also work actually. So, well, the thing is, in order to verify that, okay, whether your SSL environment is correct or not, that's why these steps are actually, and it's just internal only, so you can always use any of these steps. And here, even when if you're configuring a telnet, I'm not prepared for the demo. If you are using for a telnet SSL, so the telnet might ask for, okay, the certificate is not found. It usually comes and check in here. So if you import the certificate into here, then it will not ask that. It will simply connect it. Go ahead.
When you said yes to that, when it warned you, and you said yes, does it update this area?
Not here actually, not in the trusted certificate. It won't show here. I have to import it then.
You have to physically put it in there.
Yes.
After you say yes once, it'll warn you again.
It won't,
Unless the other end changes, then that could be suspicious, or it could mean that the other end updated their certificate. A lot of organizations have their own PKI server, so they may have an internal authority that's only recognized inside the organization. But of course, that won't work if you have customers connecting.
But I'm thinking yes, and it's very similar. I don't think any early on for some of the stuff that that'd be the same as enter the password. Password incorrect. You want to just skip it? Yeah. That's how secure PCs. I think my bank won't set up that. We just say, oh, no, let me in anyway. Okay. I don't know if that's good.
I get suspicious of what the organizations that just use the domain control validated certificates, like the kind from Let's Encrypt.
Yeah, so the fields of the certificate itself can be used for the validation like subdomains only can be allowed. So there are different purposes of the certificates. I did not show that fields as well. I'm not using any of those. Yeah. Okay, that's all. Any other questions? Thank you.
Thank you.